Okay, in this video, we're going to look at solving equations with variables on both sides, including the use of the distributive property. So here's an example. You can see that we have the variable x, and it is on both sides. And we are also going to learn in this video how to use the distributive property. So let's take a look at today's notes. All right, so here's today's notes page, and I'm going to zoom in. First, let's start with the steps that we must follow in order to get these correct, okay? We're going to need to, first of all, consider using the distributive property, if necessary. It's not always part of the equation. We are going to have to combine like terms next. Then we're going to get the variables all on one side. We'll have to use inverse operations or opposite operations to do so. We also need to get the constants on one side, and we will be using inverse operations as well. And then finally, we're going to need to multiply and divide to solve. All right, so let's take a look at a couple of examples. So in this first example, we have 2x minus 4 plus 8x equals 5x plus 16. One thing you need to consider is looking at the variables and the constants and separating them. I'm going to do that with a highlighter here. So I'm going to highlight the variables. So we have a 2x and an 8x on the left side, and then we have a 5x on the right side. Okay. Now I'm going to highlight the constants. Notice here we have this 4, but it's really a negative 4 because the sign in front of it, the minus sign here, applies only to this 4. All right. Now let's continue looking at what we have, our constants. And then over here, we just have this plus 16. So now we're going to need to start by combining any like terms that we have. So on the left side, we have a 2x and a positive 8x. Now I can already see that I probably need to go over here and combine that 8x with the plus sign. So now I see that I have the 2x plus 8x, which is 10x. So I'm going to go ahead and write 10x on the left side. Then I'm simply going to bring down my minus 4 and go ahead and write the rest of it. Minus 4. Then always write your equal sign. And now on the right side we have 5x plus 16. Okay. So what I've done is I've combined the like terms on the left side, so I have just the variable 10x and a 5x on the right side. Now our next step is we're gonna get the variables on one side using inverse operations. So if I have this 10x over here, if I have this 5x, I need to get this together. I'm gonna bring the x's over on the left. So I have this 5x. Well, what I want to do is use inverse operations. So I'm going to subtract 5x from this side because that will cancel it, but you also have to subtract 5x from this side. So now what I have on the left side, when I subtract 10 minus 5, I have 5x. So 5x minus 4 equals, and now on the left side, all I have is 16 equals 16. All right. So now, what we've done is we've gotten the variables together on one side. Now we're going to get the constants together on one side. We're going to put it on the right side because we have the 5x or the x on the left side. So this minus 4 is going to need to be removed from the left side by using inverse operations, which is plus 4. Okay. Well, again, we do that so that we can cancel these, but you can't just do that unless you do the same thing to both sides of the equation. So now on the right side, we have to add 16 plus 4. And we add 16 plus 4, we get 20. Okay. So on the left side, we have 5x, and on the right side, we have 20. Now, to complete this problem, now the last step says to multiply or divide. Well, if we have 5 times our variable equals 20, we use the inverse operations. And instead of multiplying times 5, we're going to divide by 5. The reason we divide by 5 is because 5 divided by 5 is 1. So now the left side says 1x equals. But remember, if you're dividing the left side by 5, you use the same operation on the right side to keep it equivalent. And 20 divided by 5 is 4. And our answer is 4. All right, so let's take a look at this second example. We have 18 minus 6x equals 5 minus 4x plus 3. Okay, so first thing I want to do is combine our like terms. Well, let me go ahead and highlight the terms. Okay, so now you see that we have an 18, a 5, and a 3 that are all constants and will need to eventually be combined. And then we have a minus 6x on the left side and a minus 4x on the right. Now, step one is that we're going to combine like terms on either side. So we have a 5 and a plus 3 on the right. And we add 5 plus 3, we get 8. So I'm going to rewrite this as 18 minus 6x equals, and then 8 minus 4x, because I just combined 5 plus 3, okay? Now I have it separated on the left side and the right side. I have one constant and one variable, and one constant and one variable, okay? All right, so now it's about getting the variables together on one side. Now you can put them to the right or to the left, okay? For this example, I will do it on the right side. So this negative 6x I want to remove from this side. It's a minus, so the inverse of 8 minus 6x is plus 6x. So I will add 6x. We do that because we're trying to we're canceling the 0x. But if we add 6x to the left, we have to add 6x to the right side. I'm sorry, 6x. All right, now over here we have a negative 4x plus 6x. When we do that, we get 2x, okay? But don't forget we have this 8 here. Now that's plus because that's a positive 2x. So we have 8 plus 2x on the left side. Now on the right side we have 8 plus 2x. And of course, don't forget our equation. And then on the left side, we're just going to bring down 18. So we bring down 18. We have that right here, 18. So now we want to get the 18 and the 8 together on the other side, the left side. So I've got to remove this 8. We're going to use the opposite of, this is a positive 8 over here because there's not a negative sign in front of it. So it's positive 8. So to get rid of that, we're going to subtract 8. And we got to do that from both sides, okay? On the right side, it cancels. And on the left side, you have 18 minus 8, which is 10. So now our equation says 10 equals 2x. And now you just simply have a one-step equation. The x is being multiplied by 2. So if we want to solve for x, we do the inverse, which is to divide by 2. And 10 divided by 2 is 5. So 5 equals x, or x equals 5, and that's our answer. X equals 5. Okay, now we need to consider the distributive property, because ultimately we're going to be solving equations with variables on both sides and having to use the distributive property. So here is some examples of the distributive property. These letters just kind of represent, variables. But if you have a number outside of a parentheses and you multiplying it times, if you have a times b plus c, okay. Normally we would do order of operation. We do the parentheses first inside the parentheses, and then we'd multiply. But what we can also see here is that a times b is ab, and then bring down our plus sign, and a times c is ac, and then we can add this, okay? So this is a diagram of the distributive property, and I'm going to show you why we're going to use this concept where you multiply each term inside the parentheses times the term on the outside, okay? So let's take a look at a couple examples, and this will make sense. So in example 1, we have 3 times 2x plus 5. Now, you cannot add 2x plus 5. That doesn't equal 7x, okay? This is a variable term, and this is a constant term. They don't go together. It doesn't say 2x plus 5x. So in order to multiply all of this inside the parentheses times 3, we're going to multiply them individually. So we're going to multiply the 3 times 2x, and then we're going to multiply the 3 times 5. All right. Now, when we do that, when we do 3 times 2x, we get 6x. And you can bring down your plus sign, if you want to think of it that way. Bring down your plus sign, and then you do 3 times 5, and 3 times 5 is 15. Now, another way to think of that is instead of bringing down your plus sign, you could just say that's a positive 5 times 15, or times 3 gives you a positive 15. But this 3 times 2x plus 5 becomes 6x plus 15. That's called the distributive property. All right, now let's look at this other one here. Let's look at example 2. There's different ways to use this, but we have a 4x minus 2 in parentheses times 5. So we're going to distribute the 5 to both of these terms. So 5 times 4x is 20x. Okay? And then I like to think of this as a negative 2. So we have the, I'm going to highlight, we had the 4x, and now we have the minus 2. So when you multiply the 5 times negative 2, you get negative 10. And then that would be the new expression. 20x minus 10 is what you get when you multiply 4x minus 2 times 5. Okay? A couple more quick examples. So we have negative 2 times x plus 6. Now the negative's on the outside, okay? So again, I'm going to highlight my terms. This is a negative 2, right? On the outside, this is a 1x, all right? And then this is a plus 6. So I am going to multiply negative 2 times x and negative 2 times 6. All right, so negative 2 times x, that's negative 2x. Negative 2 times positive 6, that's negative 12. Negative 12. All right, and then this last example over here, again, I'm going to separate my terms. So I'm going to highlight the 2x and the minus 3. And then I am multiplying all of this negative 5 times both of those terms. So when I do that, negative 5 times 2x is negative 10x. And then when I multiply negative 5 times negative 3, remember that a negative times a negative gives you a positive. So we would have plus 15, plus 15. Okay, that's a use of the distributive property. And I'm going to stop this video here. And the next video, we will apply the distributive property to solving equations.